Welcome to Specialized Space, your gateway to cosmic adventures. The James Webb Space Telescope has been utilizing its powerful infrared imaginative and prescient to discover a number of the oldest and maximum remote structures within the universe. Time and once more, it has shown that the good-sized stretches of the cosmos seem detached to our expectations, and the invention of these distant realms often disrupts our knowledge of standard cosmology. For example, one of the maximum difficult questions is how galaxies the dimensions of our Milky Way should have formed so quickly after the Big Bang, something that modern theories have not begun to absolutely give an explanation for. But this is not the simplest mystery that Webb has unveiled. The discoveries made are a ways extra numerous, revealing phenomena that challenge traditional thinking. Just as day cannot exist without nighttime, the ebb and glide of planets orbiting their respective stars are deeply interwoven. This connection, but isn't unique to our sun system. When we look past our galaxy, we have a look at that planets orbiting stars outdoor our sun, are characterized on the whole by means of this very trait. They revolve round stars aside from our very own. That being said, not all planets follow this sample. Some rogue planets flow through space independently of stars, defying the great assumption that each one planets have to be star-certain. These rogue planets may also both have by no means been gravitationally related to a celeb or have been ejected from their original structures after formation. Known as lonely stars, those are bodies shaped under specific situations than common stars or brown dwarfs, often emerging from the contraction of stellar gas clouds. Despite their intriguing nature, those planets are notoriously hard to detect, as they do now not emit visible light and most effective faintly mirror-mild from remote stars. However, infrared telescopes like Webb's can hit upon the heat emitted via those rogue planets, imparting new insights into their occurrence. Surprisingly, studies recommend rogue planets are some distance more common than anticipated, with estimates indicating that the Milky Way may want to host twice as many rogue planets as stars. The Orion Nebula, a star-forming location placed just 1,350 miles from Earth, has garnered huge attention from Webb's infrared cameras. It is home to over 2,800 inactive young stars and a wealth of different celestial items. Webb's current imaging has provided us with a in no way earlier than visible view of this star nursery, revealing, among other matters, 40 free-floating planets, rogue planets without discerned stars. These large objects, every so often called jumbos, have raised eyebrows among astronomers because of their uncommon size and conduct. The discovery of those jumbos offers an exciting puzzle. Many of them exist in pairs, a rarity for celestial bodies of this kind. Researchers now face the challenge of explaining why these planets appear to decide upon the corporation of one another. Through careful study of Webb's facts, scientists have determined that those stars are younger, with floor temperatures around 1,000 degrees Celsius, notably cool for stars of their mass. These jumbos are just starting their journey through superstar formation, imparting a glimpse into the early evolution of big celestial bodies. In addition to the jumbos, Webb's observations have uncovered numerous different mysteries. The Orion Nebula's population of jumbos gives a thrilling window into the formation of stars and planets in environments a ways distinctive from our sun machine. One idea is that those jumbos fashioned in a region with inadequate hydrogen density to create genuine stars, ensuing in a kind of failed stars scenario. Another possibility is that these gadgets started out their lives as gasoline giants, most effective to be ejected from their original structures because of external forces. These rogue jumbos task present models of stellar formation, providing opportunities for new insights into the cosmic strategies that form our universe. Webb has also contributed to a deeper information of the cosmos by way of revealing the existence of not possible galaxies. These galaxies shaped simply 500–700 million years after the Big Bang and incorporate famous person masses as high as 100 billion sun-hundreds, a ways larger than formerly notion viable in such an early stage of the universe. These galaxies, nicknamed universe breakers, defy traditional models of galaxy and big-name formation, which recommend that there has been no longer enough regular remember to allow for such speedy superstar creation in the early universe. This discovery forces us to rethink what we know approximately early cosmic conditions and opens the door to the opportunity of undiscovered forces or special materials that would have contributed to the speedy formation of those huge systems. Another vast finding worries a supermassive black hole detected through Webb in a galaxy shaped just 770 million years after the Big Bang. This black hollow, which weighs over 1 billion times the mass of our Sun, challenges our expertise of black hole formation and growth at some stage in the early universe. Despite its big length, researchers have been not able to pinpoint what brought about such speedy enlargement, further deepening the mystery surrounding the early universe's dynamics. Similarly, Webb's observations have introduced attention to the so-known as Hubble anxiety, a discrepancy between the determined charge of the universe's expansion and theoretical predictions. This anxiety suggests that our knowledge of cosmic enlargement may be incomplete and that new, unknown factors could be influencing the charge at which the universe is growing. The second issue is the so-known as Hubble anxiety, which is present. Using the Hubble regular as a start line, you'll theoretically determine the pace at which the universe is expanding. One odd contradiction, then again, has been determined in prior studies. In spite of the truth that the Hubble constant that's liable for accounting for cosmic history radiation has a theoretical value of 67 kilometers in keeping with second per megaparsec, the numbers that researchers located had been extensively extra. When pink giants, supernovae, and the only of a type Cepheid big name kind are considered, a determinant of 73 kilometers according to second per megaparsec is abruptly reached alternatively. The life of those systems invitations us to rethink what we knew about the primordial universe, potentially starting up new pathways for know-how darkish be counted, darkish power, and the cosmic forces that shaped the early cosmos. To the same extent as we did with the jumbos, we need to inquire about the diploma to which our theoretical model of the development of the cosmos corresponds to the processes which are without a doubt taking place inside the cosmos. The large black hollow that become detected through the James Webb Telescope in a galaxy that changed into additionally born inside the early stages of the universe is just as mysterious. In spite of the reality that this existed 770 million years after the Big Bang, it had a gravitational monster that was larger than 1 billion sun loads in its middle. As we retain to discover those and other mysteries, Webb's groundbreaking discoveries urge us to reconsider a lot of our assumptions about the universe. From rogue planets to universe-breaking galaxies, the telescope is imparting us with useful insights into the origins and evolution of the cosmos. It's clear that we're only scratching the surface of what Webb can screen. Our information of the universe may be undergoing a profound shift, and these discoveries provide the thrilling opportunity that we might also in the future find answers to some of the best cosmic questions. Consequently, does this constitute a pattern of systematic measuring mistake that has befell for the duration of history? As a result of the discoveries of the James Webb Telescope, the Hubble tension has been showed. Consequently, that isn't an alternative. There is a possibility that the universe is expanding at a quicker fee than what's presently accounted for within the cosmological widespread model. This might be due to the presence of an unorthodox form of darkish strength or darkish depend, for example. Additionally, it's miles feasible that there are debris or fields which have never been heard of earlier than, or that our knowledge of gravity has been faulty. Thank you for joining us in this journey. Your curiosity fuels our exploration of the cosmos. Don't forget to subscribe and spark off notifications so you can keep this adventure with us. Until next time, whilst we go paths once more in the limitless expanse of area.